Hello and welcome to this edition of Tech Talk. This is where we bring technical experts from Cisco to share their insights on specific topics selectively chosen based on most common conversation themes on our technology area in community. It's an effort to share valuable insights from Cisco experts on those popular themes. We hope you like it. My name is Lavanya and I'm the Technical Community Manager at Cisco, and today our topic for discussion will be Understanding Cisco Unified Communications Security. Our expert joining me today is Akhil Behl. He is a solution architect with Cisco Advanced Services based at India with broad experience in Cisco collaboration and security architecture. He has over 10 years of experience in the IT industry. He holds dual CCI certification in voice and security and also holds PMP, ITIL, VMware, VCP and MCP certifications. He is the author of the book titled Securing Cisco IP Telephony Network by Cisco Press. Welcome, Akhil.
Thank you, Lavanya. It's a pleasure being here with you today.
Akhil, can you tell me something more about your book?
Absolutely. The book which I have written for Cisco Press is based on securing Cisco IP telephony networks. It's a very niche area, and because it's a very niche area, people face issues while securing their IP telephony, or in other words, unified communication deployment. And at that point of time, the knowledge which I have accumulated over all these years, this is the crux of it. This book was specifically written to help people make sure that their networks are secure, they do not make the most common mistakes or the uncommon mistakes while going ahead and securing what's an asset to their organization's daily life operation, the communication channels. So you'll find everything right from a network infrastructure security to UC application security to an endpoint security, as well as a management security aspect within this book, along with building a security framework for your organization.
Today we'll discuss about unified communications security, how to secure Cisco UC products like CUCM, Unity, CUPS and Cisco IP telephony endpoints, wired, wireless and soft phones against internal and external threats. Types of certificates used for security of a UC endpoint. Finally, some questions handpicked from our community. With that in mind, Akhil, can you tell us what is UC or IP telephony security, and why should I be concerned with UC security when all my resources are within organization premises?
Absolutely, that's a great question. And to answer that, as I said earlier, UC security is something which is concerned with every organization's resources, which has deployed UC solution, not just Cisco, but any UC solution for that matter. At the end of the day, what you're working towards is securing communication channels within your organization, that is with internal stakeholders, employees, as well as the external stakeholder, your real customers. So in a world we live in today, which is always connected, people demanding resources on the go, they just want access to every organization resource. You just cannot afford to be disconnected. So at that point of time, a competition may pitch in and all your loyal customers may switch over to that. So UC security essentially is the backbone of securing the organization's asset you have in place, the communication channels. And to second part of the question, Lavanya, why you need to secure something which is internal to your organization than something which is exposed out? The real answer lies in the fact that more than 80%, statistically, more than 80% of the attacks, they originate from within the network rather than from outside. So when we consider that, and as a matter of fact, can you really believe in someone doing always the right set of things for your organization's benefit? If the person sitting next to you, if you can say, yes, I'm 100% sure, he or she is always doing things which are in favor of security of my organization's assets, you're good. But you cannot be 100% sure because you don't know what he or she might be doing. So with that said, it becomes quintessential to secure what's within your enterprise rather than what's outside. For example, a visitor can just walk in, have a PC plugged to an open switch port, get online, spoof a PC's MAC address, launch a soft client, and he's pretty much in. He has access to all the resources. So for that very reason, you just need to ensure that the security is always built from inside out, and it's a whole construct. It's not a single line of security, but a multi-layered security.
It's a great explanation, Akhil. Now let me ask, what can be secured from internal and external threats from a UC solution perspective?
Absolutely, another great question. Thanks for bringing this up, because people do ask what I can secure, how I can secure. So with that said, first let's understand what threats are there to your network. So what are the threats that really pester the sanctity of your UC network? The most prominent threat that has been there since the TDM days is toll fraud. It's still a chronic threat. It has been going on still on IP networks, voice over IP. Then of course there is identity theft, there is eavesdropping, denial of service, denying service to the legit users of the organization, phishing and vishing. So phishing is on the data side and vishing is on the voice side. Hijacking calls, taking control of the calls and landing on one's platform. Packet injection and manipulation. Last but not the least, assaulting an organization's physical resources directly, because you can have a ton of logical security applied, but at the end of the day, if someone can just walk into your data center, pull out the power plug of the switch or the router, how good is logical security? It's not going to stand there. Now what you can secure is, you can ensure that, as I said earlier, security has to be built from inside out, and it's a multi-layer construct. So securing right from network infrastructure, which is LAN and WAN, going up to layer 2 security, which is switch port security on user access side, data center access side, layer 3 security, routing protocol authentication, and so on and so forth. Secure IM, secure voice, secure conference calls, for example, and then building upon that, ensuring that the remote worker security or the teleworker security, that is there in place, because if people are traveling all around the place, they are connected to enterprise networks. You really don't want them to come over a rather insecure medium such as the internet. So some type of encryption has to be there in between, and some type of rules who should be allowed to log in and to what resources they have access to, things like AAA. Above all, once you have deployed a network, let's not forget about the security of the management system, because once you have a network out there functioning for you, you really cannot afford to let it go out of control. You have to manage it, but more importantly, manage it securely.
Thank you, Akhil. Can you tell me, how can I prevent spoofing or eavesdropping attack against my UC infrastructure or endpoint?
Absolutely. Well, spoofing is something wherein someone can get another's identity, that is identity copying. And eavesdropping, on the other hand, it's more or less a related attack. Once you have acquired identity of a legit user, you can pretty much start getting into the network, getting under the skin of the network, and start getting access to the resources. Now what that translates to, there are two ways to do it. One, you can do it at an infrastructure level. The second one is you can do it at an application level. Now when you start doing that at an infrastructure level, you can start right at layer 2, which is switching layer. You can deploy DHCP snooping for making sure that the rogue DHCP servers are thwarted or they are restrained. Then you can go for dynamic ARP inspection or DI. You can also go for switch port security, which will ensure that only a certain number of MAC addresses are allowed per switch port. On top of that, also there can be a switch MAC table which restricts anything beyond what is already in there. Then you can go for layer 3 security, and above there application layer security. Now this was specific to spoofing. When it comes to eavesdropping, either you have a network which doesn't have any open ends. Now there is no such network which would not have any open ends. Yes, you would, for your convenience or for the convenience of visitors and so on and so forth. So what you really need to ensure is that if your network is open to anyone from within or outside, you encrypt your media streams, you encrypt the signaling. So say point A talking to point B, the C, which is kind of jacking in between A and B, is restrained right there, then and there, because unless C has the right set of keys to decrypt the communication, they're restrained. So eavesdropping, maximum security can be attained by using encryption. Could be IPsec at layer 3 and 4, or could be TLS for signaling and SRTP at the application layer.
Okay. Akhil, I would like to know more about the certificates. So what are the different types of certificates used for security of a UC endpoint?
Absolutely. There are a plethora of certificates, so a ton of certificates which you can leverage for different functions. So what that means is, as you can see, there is security by default. Now this is a very recent feature which was introduced by CUCM 8.x and later releases. So you have security by default certificate, which is ITL file, which gets downloaded to the phone, rendering it to register only with the cluster with which it was registered originally. So if you move the phone between clusters, unless you get rid of that ITL file, it's going to stay there. Then of course you have IPsec certificates, because you want to create tunnel between an H323 endpoint and call manager, or an MGCP endpoint and a call manager, or call manager to any other third-party device per se, because IPsec is standards-based. So you have those certificates, and then there are CAPF certificates, which are closely bundled with MIC and LSCs. MIC is manufacturing install certificates, which come originally on an endpoint like a Cisco IP phone from Cisco Manufacturing CA, and LSCs are locally significant certificates, which are for which CAPF is a root, and while using the CAPF and the proxy function, they do generate LSCs which you can download and use them for SRTP and TLS for signaling. Similarly, there are VPN certificates as well, as you can see, and these are for the VPN phones, which you can use as a on-the-go phone. You can just carry the hardware around, plug it on the internet, you're good to go. You have access to all your enterprise resources. And then there are likes of Tomcat certificates, which in later releases 8.x and onwards, Tomcat is also used for directory services. Earlier, pre-8.x, we used to have directory services certificate. So Tomcat can be used, and it can be enrolled with, let's say, a third-party CA provider to ensure that you don't get the HTTP error you would normally on a web page. So as I said, there are a ton of certificates, all with their specific functions, and they can all be leveraged. Some of these are internal to CUCM. They are self-generated, self-signed. Some of them, they can be signed by an external CA authority to ensure that your call manager certificates are in line with the overall organization certificate paradigm.
Okay. Akhil, related to your answer, can you explain more about SBD, security by default feature?
Absolutely, it's a wonderful feature. I would say it's. I'm glad that Cisco BU and Cisco, they finally came out with this feature. Now, security by default can be best explained in two folds. So, what security by default is? It is a feature which is only available from version 8.x onwards. It is not a pre-8.x feature. And what that does in a nutshell, it enables two sub-features. One is initial trust list, or ITL, and the other one is TVS, or trust verification service. Now what ITL does is, as soon as on a 8.x or 8.5 or a 9.0 call manager, the moment you register a phone, the moment, I'll take a step back. So the moment you build a cluster, automatically the cluster is building an ITL file which contains the host name and IP addresses for all the members of the cluster. And the moment you register a phone, this ITL file gets downloaded to the RAM of the phone, not the non-volatile RAM, but volatile RAM of the phone, and then it stays there. Now what that tells the phone, these are the IP addresses or host names you can trust while you're transacting with the cluster. So the moment you take off the phone and bring it to another cluster, it won't register. Now the second part to SBD, or security by default, is trust verification service, also known as TVS. What that does is, the moment the phone has to get a service, it'll ask its call manager subscriber, can I trust this? So for example, the phone is trying to retrieve an EM URL, an extension mobility URL. Now the moment you press services, it's going to contact TFTP for retrieving the URL and the profile. So at that time, it'll ask its subscriber, can I trust this TVS? Can I trust this TFTP server? Yes? Okay, I'll go ahead and download that profile. If not, the operation will be cancelled and the phone will just sit there. It will not obey what you just asked it to do.
Okay, it's a great explanation, Akhil.
Oh, sure.
My next question to you is, how can I secure the UC products like CUCM Unity Presence gateways and the Cisco IP telephony endpoints, wired, wireless and soft phones against internal and external threats? I know it's a wider question, but let me ask from users' interest.
Oh, absolutely. As you just mentioned, this is not just a wide question, it's a vast question. It's a mammoth question. Why so? Because you're asking about how to secure right from an endpoint to a device to an application to what that application pertains to. So you're asking about the security of the overall ecosystem. So I would like to narrow down the view and come in from a perspective that how really you can go about it. As I said earlier, it's security is, if you really want to go for an end-to-end secure network, you have to follow the defense in depth approach, which is security at all layers where possible. So what you start building upon is where your organization is coming from, what business vertical your organization belongs to. Now why I say that is a bank or a financial institution would have different security requirements compared to a university or a school. And that compared to a government agency would have even more restricted security policies. Now, depending upon where the business is coming from, what their requirements from the system are, what they want to achieve with the system, that gives rise to the security policy. Now, this security policy is not data security policy, but it's very specific to UC. So it has to, because voice travels on data as voice over IP, but it is not data. It has to be treated separately. It has certain set of requirements which data networks can or cannot attain. Now, with that said, depending upon what your business vertical is, you have to develop or you need to develop a UC security specific policy, and built on that, giving directions, secure network infrastructure, which can be right from routers to switches to gateways, and built upon a secure network infrastructure, finally what you'll have is secure UC applications. And within the network infrastructure and UC applications, within those two paradigms, you'll see the UC endpoints fitting in, because endpoints connect with the infrastructure but rely on the application. So as I said, it's a multi-level construct. It's a 360-degree cycle which has to be operated because it's governed by the security requirements and the needs of an organization. But really, at the end of the day, the organization has to say, okay, this is the policy we are going to follow for people inside, for people outside, for employees, and so on and so forth.
Thank you, Akhil.
Sure.
Just for refreshing my memory, can you explain PKI, that is public key infrastructure pertaining to Cisco UC?
Oh, absolutely. It's a great thing. So PKI, public key infrastructure, as we know it today, was established back in 1980. It's an international standard, and anybody doing asymmetric keys and certificates has to follow this model. And Cisco is no different. They are doing all standards based. So at the end of the day, what we have is every UC application. I'll take an example: Call Manager, CUCM, Cisco Communication Manager, Cisco Unity Connection, Cisco Presence Server. All of these, they come with built-in CA structure. So they are self-contained certificate authorities with Cisco root serving as the CA root, and they have self-signed, self-assigned certificates. So if you ever log into the OS administration GUI of CUCM and go to certificate management, you'll see all sort of certificates. Now, where are they coming from? Those were generated automatically as soon as the system installed itself, and they start providing some level of default security and service. For example, Tomcat, the moment you try and access UCM web page, you'll see HTTPS. So your IP address or host name is automatically redirected to a secure URL. So that magic is happening in the background. Now, how this really functions is, again, it's all built on standards. As you can see, if A wants to talk to B, say phone A wants to talk to phone B, how does phone A trust it is going to talk to phone B, and if B is a trusted identity? So there has to be a median somewhere, and that medium is the certificate authority. So as you can see, the common trust point or the root is going to issue certificates to A and to B and give its public key. So when A talks to B, it encrypts the data with, in this case, if it's phones, then it's going to be RTP, which is really secure RTP. So it's going to encrypt the data, send it across, and B is going to decrypt it using its public key, which has been signed again by the trust introducer, which is the common certificate authority. So this is really in a nutshell how Cisco UC PKI works. And as I said, there are tons of certificates out there, right from CAPF to IPsec to VPN phone, so on and so forth. And this C authority can be found on almost every UC product.
Akhil, I would say it's a very good explanation. I hope this gives a better clarity to the viewers.
I hope so too.
Yeah. Can you tell me what's the difference between CTL and ITL?
Oh yeah, that's another top of the mind question which is mostly asked today by customers. So, well, I'll compare ITL to CTL in a couple of ways. One, ITL is something which is installed by default when the cluster is built. So as you keep on adding subscribers to a cluster, there is a file being formed automatically in the background, and that file is pretty much going to tell the cluster, okay, if an endpoint registers to you, this is the file which is going to download to that endpoint, and then that endpoint is only going to trust these IP addresses. So ITL is something which is automatically formed, whereas CTL is something which is only formed when CAPF service and CTL proxy services are activated on a cluster, plus the CTL client, which is downloaded from plugins. You can go to your call manager administration GUI and download the CTL client. So once that is done, you run the CTL client with USB E tokens, only then the CTL file is formed. And then the other major difference is ITL is implicit to every phone on the cluster. CTL is an explicit form. It is only downloaded on the phones or only applied on the phones where you want it to be. So you say this is a secure phone, then only CTL will get on top of that phone or get downloaded to NVRAM of that phone. One other major difference is ITL, even though it tells the phone this cluster to trust, these subscribers to trust, it cannot help you attain secure signaling or media. Still, you need to have CTL on the phone to be able to do TLS for signaling or SRTP for media. So CTL is still required for secure signaling and media. ITL cannot help there.
Thank you, Akhil. Recently, when I was handling a case, I have seen a customer who was trying to upgrade his network from CUCM 7.x secure cluster to CUCM 8.x, but the phones do not get registered automatically. Can you explain why?
Well, there could be a multitude of reasons for that. What I would suggest is looking at, okay, if I upgraded from a 7.x to an 8.x, the implicit governance is that the moment the cluster is upgraded, the new cluster is going to have ITL files which will start downloading to the phones. So that could be something to look at if the endpoints did get their ITL file. If not, you can try resetting the endpoints maybe in bulk using device pool reset, so they do get their right CTL files. The other one would be something went wrong with the certificates, and that's the most commonly seen issue. So to overcome that issue, what you need to do is you need to rerun the CTL client on the upgraded cluster, make sure that it goes through. You use the same USB E tokens which you used to secure the cluster in 7.x. So once 8.x is attained, you rerun the CTL client with the new CTL client downloaded from the admin page, plugins, download for Windows or Linux, whichever version you're using on your OS, on your laptop or PC. Once you've downloaded it, just log into CTL client, run it through, make sure you use the same USB E tokens which you used in 7.x, And I think after that, you should be all good to go.
Okay, thank you. Another question. See, if a customer is using UC proxy on their phones over the internet, will they still need a CTL file?
Oh, absolutely. Because when you talk about UC proxy, what you're talking about is, in a nutshell, you're talking about ASA sitting in between call manager and the IP phone. So at the end of the day, ASA to call manager, it pertains or it emulates an IP phone. On the other end, for an IP phone, ASA is emulating a call manager. So since it is sitting between two devices, it's proxying the connections. What is happening is ASA needs to trust call manager needs to trust ASA. On the other hand, ASA needs to trust IP phone needs to trust ASA. And for the mutual trust to establish between two or more devices, you need certificates. And for certificates, we do need CTL, because without CTL, the endpoint cannot originate secure RTP or secure signaling, which will terminate on ASA, and ASA will decrypt, look at the signaling, re-encrypt it, and send it to call manager. So at the end of the day, call manager never knows there is an ASA in between, phone doesn't know there is an ASA in between, and it seems like phone to call manager was a transparent connection. So again, wherever certificates are involved, CTL has to pitch in.
Thank you, Akhil. Let me ask a few questions that our community users are asking.
Absolutely.
Yeah. I moved my phone from one cluster to the another cluster, but the phones do not get registered. Can you explain why?
Right. So that could be, again, because of multiple reasons. But the most common reason is once someone has upgraded to 8.x, or if you are on 8.x already per se, and you're moving from one 8.x cluster, you take off the phone, you just plug it to the other switch port, do a new VLAN or do a static TFTP, the phone no longer registers. Why? Because it's pretty simple. Look at the ITL file. What are the contents of the ITL file? Now, if the ITL file still pertains to or it relates to the earlier cluster, of course, the phone is not going to register with the new cluster because the ITL file does not have the hostname or IP addresses for this cluster. So what you need to do to resolve this issue or to mitigate this issue is you can either clear the ITL file from the phone security settings, you can erase ITL, or you can reset the phone back to factory defaults. That should remove ITL file. So the phone comes up afresh, talks through the TFTP of the new cluster, downloads ITL file, and you're good to go.
Okay, thank you.
You're welcome.
Can you explain how to do the bulk certificate export for CUCM?
Oh, absolutely. Another good question which usually comes in handy when you're trying to consolidate certificates or when you're trying to do extension mobility cross-cluster, which are a couple of services which do require certificate export. So it's pretty easy. All you need to do is to go to the call manager OS admin GUI. Again, it's OS admin, not the regular admin. Once you log in with the OS admin credentials, there is an option for certificate management. Under certificate management, you have an option to do a bulk certificate export, which you can then you can play around with the certificates, look at their content, or use them for extension mobility cross cluster, and so on and so forth.
Thank you, Akhil. My next question is related to e-tokens. How can I obtain CUCM hardware e-token, and how can I use them to convert a cluster into mixed mode cluster?
Good question. Well, people usually fret about, I need e-tokens, but I don't know how to get it. So there are a couple of ways to get it. One, you can, if you have the right part number, which is right there. So you can have key CCM admin K9 or key UCM admin 2 K9, depending upon whatever is available for your call manager version. You can either order it from Cisco.com or ask your account team to get them for you. So usually they should, well, it can be ordered as a single e-token, but you need a pair, at least a pair of those to successfully convert a cluster from a non-secure cluster to a mixed mode or a secure cluster. The recommendation, my personal recommendation would be to get at least 4 of those, and you can reuse them between clusters. So if you have like 4 clusters, or maybe 10 clusters, you can reuse your e-tokens. But getting more e-tokens means you are increasing the level of redundancy. So in case even if you lose like 2 e-tokens, you're still left with 2. Because once you secure a cluster with an e-token, then you are bound with it. The same e-token would be required again if you add a new subscriber to the cluster and you want to secure that as well. Or you delete a subscriber from the cluster, then too you need to rerun CTL client. The same e-tokens will be required. Now coming to the other part of your question, Lavanya, how does Cisco CTL client can help? How does that help you to get to a secure mode? So that's pretty easy. Again, go to Call Manager admin page, go to plugins, download the version of CTL client for Windows, 64-bit, 32-bit, whichever you have on your PC or laptop. At the end of the day, once you have that, install it and make sure that the Windows Smart Card service is enabled. So once that is done, you got to log in to the CTL client with the CUCM administration credentials, which you will use to enter into the CUCM admin GUI, not the OS admin. So once you punch in the host name or the IP address for CUCM, provide the right credentials, you are in. It gives you an option what you want to do. You want to convert the cluster to a mixed mode, so you choose that, go next. It's a pretty self-explanatory process, so you just browse through that, and whenever it asks you to plug in one of the e-tokens, which is really a USB key, you plug it in, have it run through. When it says all done, take out this token, insert second token, run through that, and you should be all set. But as I said earlier, it's always good to have more than 2 tokens, so you can add more tokens while you're at it.
Thank you. Next question is, what ports needs to be open for CUCM or Unity connection, CUPS, gateways, and Cisco IP telephony endpoints for secure communication?
Well, that is a vast question. That's a really a vast question. What I would like to do is put it in perspective. So you might have a set of applications. You might have Call Manager, you might have Unity Connection and CUPS, and you have H323 gateways, or you might have MGCP. You might even have SIP running for all your devices, including phones and gateways. So assuming that you have a data center where all the UC applications are located and everything else is outside, like there are endpoints at different sites which connect to the data center, and you have gateways local to the sites. So what you really should do to ensure you have maximum compatibility while traversing from a remote site to the data center, maybe through a bunch of firewalls, which could be Cisco firewalls or third-party firewalls. So if you have Cisco ASA, it has intelligence to look into the packet and open up pinholes on both sides. So that's known as application level inspection. And what you really want to do is look on CCO for the right version of the application you have. Say, if you want to look for what ports do I need for Call Manager 9.x or Unity Connection 9.x, you should be looking for security guide for that product, and look for the security guide of that product for that version. So you get the list of ports which you can open up on the firewall or on router ACLs on the way to the data center, and from the data center out to the remote sites.
Okay, thank you. Finally, Akhil, how can I ensure an end-to-end security construct for my UC network?
A great question. Something which most organizations do not even pay attention to. They say, we have a secure network infrastructure, so we are running security everywhere. Why do I need to secure UC applications? Which is good. You have secure network infrastructure, but what happens if you are still using plain RTP? Someone somewhere is intelligent enough to overcome your defenses. At the end of the day, your RTP streams are spoofed, they are eavesdropped, and someone can replay them, can sell the information to a competition maybe. So what you really want to do, and it's a recommendation, go in a phased manner for security, build it inside out, and build it in different steps. So the first step is what your organization does, what its core business is, and depending on that, derive the security requirements, which will ultimately lead to formation of a UC security policy. And that security policy guides the other steps, which is, as you can see here, first you need to have a secure network, because with a weak foundation, even if you have secure call manager or secure Unity connection, it will not help if someone can just walk into the data center and plug out the power to a switch or a router. I mean, just a simple example, how important physical security can be. So the right level of physical security, as well as network logical security at layer 2, layer 3, layer 4, right from LAN switching infrastructure to WAN switching, which is layer 3, and then you also have perimeter, which is guarded by ASA firewalls or maybe intrusion detection prevention systems. Once you have that layer secured, it's time to pay attention to the topmost layer, which is UC application security, because that's what is the core to your business, your communication channels. So you really want to have, say, SRTP running or maybe authenticated calls. It really depends upon what the bottommost layer says. What was found as a gap during UC security assessment and what it lead to is a UC security policy based upon the business processes as well as the business requirement. So it's a multi-level construct. It's not a single level thing. And end of day, how do you really achieve an end-to-end security? That's right there, demystified for you. Make sure you have good physical security construct. Could be as common as a CCTV camera to as complex as motion detectors within data centers. Then going on to network security, because network is the base. UC is an application, it runs on network, it needs hardware, touch and feel devices to run on. So really, hardware security, right from switch port security to routing protocol authentication to wireless security, not using things like web, which can be easily broken in like 5 minutes or less, but use enterprise level security like WPA, PSK2, so on and so forth. So things like those. And finally, moving on to the last column where you see the UC application security, call control, voice messaging, presence, soft clients, on-the-go mobile workers, telecommuter security. So that's really how you can do an end-to-end security construct.
Akhil, I would say really it's a very good explanation.
Thank you very much. I hope it helps the audience.
Yeah. Thank you, Akhil, for sharing your expertise with us. I think that was a great presentation and insights.
Thank you.
Hope this tech talk on understanding Cisco Unified Communication Security was useful to you, and we look forward for your feedback. You can send in your feedback using the comments section. You may also ask questions and collaborate via various social media channels like Facebook and Twitter. You can also catch us on YouTube, Google+, and LinkedIn. Goodbye, and thank you for watching.